products, right, that I wrote down to you. And I hope I did them correctly. Please if you mistakes and use my words to let me know how to make mistakes sometimes. I won't feel offended. Fine. Okay, so the first one was just a fraction one. So busy coming on there. Oops. So it was x over 5 minus y over 10 times 2.5x plus 1 and 1 over 5. 1 over 5. So there we go. Now what I did in this one is 2.5x. I just decided to put the x in the numerator because the other terms were that way. But it's fine if you left the x next to it. So if you wrote 5 over 2 and then the x, that's okay. Right, and then when I twirl them out, actually none of these were like terms, so you can add in them together. I got a very different answer. You had a different question. Oh yeah, different question. Oh, I see. Oh, lovely. Okay, you guys see it. Sorry, I don't know what I. This. Oh, what? Did I use this one twice? I talking. Okay, let's see. Yes. Okay. So first one was supposed to be a 4 now. Yeah. Sorry, guys. You see that I used this bracket in the first question and the last question. Sorry, I didn't look properly. Actually, I was just testing you guys, and you did pass. Well done. Okay, so I'll just fix that. Just quickly, what was the answer to that one? X squared minus y squared over 4.
Yeah.
Okay.
X so the easy awkward or X away. Separate. Minus.
Oh.
Yeah.
Okay, sorry. X squared as one term and then minus y squared. Okay, perfect. Thank you. Okay, cool. Just thank you guys. I will do it. I'm not going to do it now. Okay, guys. So this was the answer, but I will just redo it a little bit later, and then I'll show you the working. Sorry about that. Did I jinx myself by saying that was okay, so that was the answer. Okay, number 2. Now what I did was I tried to do that instead of the grouping thing because when I looked at these two brackets, I saw, okay, we have a 2x minus y and a 2x minus y. Right, so I can group those two together just by putting a bracket around it. And then I have a 3z plus 4. And here I have a negative 3z minus 4. So if I take out negative 1 as a common factor from these two, then I will actually end up with the same bracket. Right? Did you notice that? Guys, if you didn't see that, I mean, I didn't do the other method, so I don't know how long it would have taken. But I have a suspicion that this method is maybe more steps, just less multiplying out. That makes sense. What you could have done is you could have done 2x times all 4 of them. And then negative y times all 4 of them. And then 3z times all 4 of them. And then plus 4 times all 4 of them. All right, that will give you 16 terms, and then you must collect like this. That's fine. All right, it's more multiplying out. Where mine is more steps, but it's less multiplying out. Okay, so I'm just going to go through my method. If you did the normal multiplying out and simplify it, that's perfectly fine. But I did that grouping thing so that I have the same 2 brackets there and I have the same 2 brackets here. And do we notice that there's a plus in between these 2 terms and a minus in between these 2 terms? So this is that difference of 2 squares thing, right? Where if you have the same 2 terms but a plus and a minus, then you can just take the square of the first term and then minus the difference of 2 squares and then the square of the last term. Okay, again, if you don't like this, don't panic. Okay, you can just do the traditional multiplying out. There's nothing wrong with that. Then from here, I just did that shortcut that I showed you guys on Friday. That's one of you knew from grade 9 already. Where if you are squaring a binomial, you take the first term squared. Remember how do you get your middle term? You multiply these together and then double it. Right? Times it by 2. So that's where negative 4xy comes from. 2x times negative y is negative 2xy. Times 2 is negative 4xy. Okay, that's where that middle term comes from. And then the negative y, the last term, when you square that, will give you positive y squared. Now guys, something that might have tripped you up here is when you are now squaring this binomial, please notice that you're supposed to subtract the whole binomial squared. Meaning that all three terms that you get from squaring this binomial, you have to subtract. And the only way to do that is to put brackets around them so that you can multiply that -1 in. Okay, some of you might be able to do this in one step where you remember the minus must go in and you multiply it in your head. That's fine. Okay, but does it make sense that if it's negative a bracket squared, you need to keep the brackets there so that you can subtract all three terms that you're getting? Right? You're supposed to be subtracting the whole binomial squared. So there we have 3z squared is 9z squared. Then if you multiply these two together, we get 12z, right? Then we must double that. So that's where the 24z comes from. And then 4 squared is 16. Then you're going to multiply that minus into the bracket, and we end up with that. And then we didn't have like terms in it. Yes.
So, wait, second step. Second sentence, right? 2 squared minus y and minus 4. Out the common
-1.
negative positive. When you're making the 3 positive, why does the minus stop?
Because when you're taking out -1 as a common factor, you divide by -1. So -3z divided by -1 is positive 3z. And -4 divided by -1 is positive 4.
Would it with already have a negative positive?
I'm dividing by -1. It's almost like a switch around this. Not exactly. Okay, guys, you are going to practice some more of these today. Okay, so if you weren't able to do it like this and you still really want to try, I'm going to give you trouble. Okay, then number 3, did I write this question down correctly? And is my answer correct?
Yes.
Okay, thank you. Yes.
Cross function.
That's
In
right.
the bracket. So it's like,
Oh,
so Owen. So I.
so the problem with cross cancelling, remember when you are multiplying two terms by two terms, right? You're not just going to do this by this and then cancel off, because you're going to still multiply -7/5 by that one as well. So you can cross cancel within a calculation, but not in the brackets. Okay, so guys, what we're talking about here is maybe you saw that, oh, there's a 5 and there's a 5, I'm going to cancel them out. You can't actually do that if you have multiple terms in your bracket, because what is happening here is you need to multiply both of these terms by both of those terms. So yes, you are going to do this multiplication, and you can do it on the side if you want. You're going to have -7/5 times 5/2x. There you can cross cancel the 5. But you must still multiply the -7/5 by the 6/5 as well. Okay, so this product actually has nothing to do with this product. I hope that makes sense. Right? If you're not understanding, you can just ask me afterwards. Okay, but it's better to do a FOIL thing. Whenever you're doing a binomial multiplied by a binomial, FOIL thing out. Okay, are you guys a bit iffy on fractions? Okay, some of you, I don't know, I see a few blank faces, but maybe I'm still just know your expression. Okay, we are going to do some more examples now. We will do the textbooks in a little while when you guys are starting your homework, all right? But we are actually going to carry on with some more complex products. I have written down 2 here that I want you to do on your own, and then we're going to discuss a pattern that we are going to apply in the next one. Okay, so just write that heading. And when I say more complex, I don't mean that they are more difficult, I just mean more of them. Does that make sense? All right, so more of this product, the type of product questions that we were doing on Friday. No, not yet. Okay, guys, for this, we have in both of these questions a binomial multiplied by a trinomial, which you did last year, right? So you have 2 terms multiplied by 3 terms. Remember, you must just take the a multiplied by all 3 terms. Then you must take the -b, multiply that by all 3 terms, and simplify. Okay, so however many terms start with have the first bracket, you multiply all of them by all of the terms in the second bracket. Please do those first two on your own and see if you can recognize the pattern. Okay, once you've multiplied out and simplified, see if you can find some kind of pattern between the question and then the answers. Okay, but do both of them first, please, before you try and do that.
One.
No. You just multiply out.
Is this the question? That's one one thing. I think that.
Yeah, so we're gonna just have to look at what actually needs to happen in the question. Like we need to look at that pattern and then it will give us this cycle. It's almost like that difference of two squares. You have the two terms, the one plus the other one combined, so you always get a constant. And we're gonna talk about that now.
Fine.
Yeah, but they have to be as a certain, there have to be a relationship between the factors or the terms in the bracket. Not just any binomial and any time. All right, so we'll talk about that. Come on. Okay, guys, I'm just going to show you my answers and then we can discuss the pattern. It's fine if you have 5 minutes. I'm trying just to look at that. Okay, just double check that you got the same answers there. So guys, again, so we're going to discuss what the pattern is now and why we are getting this type of answer. But we got the same answer when we just multiplied out. Okay, so I don't want you to panic. Like I said on Friday, I don't want you to think, oh gosh, this is now another thing that I must remember. And if I don't remember it, I'm not going to get it right. You can still multiply it out in the traditional way. Okay, but it can save us some time if we are able to identify patterns and use them going forward. All right, so did we all get these two answers? For the first one, a cubed minus b cubed, yes. Yes, and for the next one, 27x cubed plus y cubed. Yes. Okay, yes, you can try.
So what would be the second bracket? First term was the first one.
Yes, okay, wait, let me just write that in. Let me just do that. So are we all seeing that in both of them? The first term of the trinomial is actually the first term of the binomial squared. We notice that. Okay, let me just do that. So a times a, all right? And this was 3x times 3x, or the squared, all right?
And then the second term. Times by each other and then.
Yes, okay. Are we noticing that, guys? So here, if you multiply these two terms together, right? And remember when we did the shortcut of squaring a binomial, for the middle term, we also multiplied them, right? But when we're squaring a binomial, we then multiply that answer by 2. Now look at this. If we multiply these two together, a times negative b is negative ab. So we change the sign. And the same thing happens here, right? We have 3x times y is 3xy, positive 3xy. The middle term in the binomial is negative 3xy. Okay, so it's the same term, but we're just changing the sign. Okay, yes, the last bit.
The last term is second term.
Wait, as well. All right, now here we have negative b times negative b is positive b squared. Yes, y times y is y squared. So we can do that there as well. So this was negative b squared, and this is y squared. Okay, and for your middle term, I'll write it on the side. This is a times negative b times negative 1, essentially. I want to change the sign, all right? And for this middle term, it was the two terms from the binomial multiplied together, so it was 3x times y times negative 1 again to change that sign. Okay, so that is the relationship between the two brackets. Okay, one bracket is a binomial, and then the trinomial has that thing happening. So the first term in the trinomial is always the first term here squared. But guys, remember they can also swap around the order of the terms. Okay, to maybe confuse you. They could have written b squared plus ab plus a squared. All right. So the first term squared here is one of the terms. All right. They usually don't do that, but I mean, I'm just saying it could come up.
Then,
And the last. Okay, because of the difference in signs here, because there's a minus here in the first bracket and a plus in that second bracket. The terms that we're getting here in between are always, the one is positive, the other one is negative. All right, so what I mean by that is when we are doing negative b times ab, for example, negative b times positive ab, we're getting negative ab squared, right? But then we're doing positive a times b squared, that's giving us positive ab squared, and negative ab squared and positive ab squared, they cancel each other out. All right, so it will always happen like that. And then what do we end up with? The first term multiplied by that first term is a2. This last term, negative b, multiplied by that last term is negative b cubed. Do you see that it's similar to the difference of two squares thing that we discussed on Friday? Right? Can we remember what that was again? I'll just show you that note. Yeah, the opposite of a difference of two squares. Where we had the two brackets, they were the same. The one just had a plus, the other one had a minus. Then we ended up with x times x was in our answer, and y times negative y was in our answer. All right, it's similar in this case. That our answer that we're getting is actually just the product of the first term and then the product of the last term. And guys, we call this a difference of two cubes. Right? Because you are always going to multiply something by its square. I'm going to say that again. To get the first term of the answer, you're always going to multiply something. Remember, how do we get this term? It's an a squared. It's the square of the first one, right? So we're always going to take an a multiplied by an x squared, which will give us an a cubed. Okay, and the same thing for this. So this is actually called a difference of 2 cubes. The answer is a difference of 2. But I spoiled it, we're going to have to factorize these as well. Right? When we go back to 4, that's what we're going to be doing tomorrow. Factorizing a difference of 2 cubes. We're going to end up with those 2 brackets. Remember, factorizing is the opposite of multiplying out. Yes, did we discuss that before? Alright, so now we're multiplying out, we're getting a difference of 2 cubes. Tomorrow in our 4 books, we're going to write the note. What do we do when we factorize a difference of 2 cubes? We end up with these 2 brackets. Okay, so we're also going to practice this in 4 again. Now here, we started with 3x plus 1. Right, so here, the sign in the first bracket is a plus. And what was the sign in the answer? Between the 2 terms in the answer, also a plus. You guys notice that? In the first question, the sign between the 2 terms in the binomial was a negative, and the sign in the answer was also a negative. Right? So you can always say the first bracket and the answer is linked very well. All right, the sign in the first bracket is always the sign in the answer. See, it happens here as well. The sign in the first bracket was a plus, the answer in the, well, the sign in the answer, sorry, is also a plus. Okay, what is 3x times 9x squared? 27x cubed. Is this a cube? Does this have a cube root? 27x cubed does have a cube root, right? So this is a cube. What is y times y squared? Y cubed. Is y cubed a cube? Does it have a square? Oh, sorry, a cube root. Yes. So this is also a different. It's a sum of 2 cubes because now there is a plus between them. And tomorrow we are going to discuss how do we go backwards? How do we factorize the sum of 2 cubes? With squares, we could only factorize the difference, right? We couldn't factorize the sum of 2 squares. But for cubes, we can factorize the sum or difference. Okay, so we're going to write down that practice tomorrow. Difference has a minus in between, sum has a plus. Yes. Yes, so we're going to discuss this in 4 tomorrow. We do the factorizing in 4 as well. Yes. Okay, now guys, I want us to use what we've learned here now. And we might probably be a bit iffy on it because we haven't really practiced it. Okay, so let's try our best. Let's try and apply this to this question now. Let's try this now. Number 3. Number 3.
Oh my God.
It's not our Monday.
Doesn't look like that.
Here we go. Number 3. Write it down, please. It's 2. It is. Yes, it is exactly.
Put together.
I feel like we're all having fun, right?
It is fun.
I can see fun all over your face right now. Okay, guys, at first glance, those 2 brackets look like a difference of 2 squares. Don't they? I'm saying at first glance, hey, we must still do some investigating to see what the best method to work this out would be. But guys, I mean, if you want to, you could do multiplying out. All right, as with all of these, you can use the normal multiplying out. The thing is that we have 4 brackets. Okay, so that means that you can work with 4 brackets, try and make it less first. So if you wanted to do the normal multiplying out thing, then I would multiply out the first 2 brackets, right? How many terms are you going to get from that? You multiply out 3x minus y and 3x plus y. But isn't that a difference of 2 squares? Yeah, so look at what I'm saying here. We're not going to do this now. I'm just looking at possible methods, possible things that we could do. If you're just looking at these 2 brackets, guys, this is the difference of 2 squares product. You see that because we have the same 2 terms. We have 3x and 3x, y and y, but there's a negative and a positive. So do we remember the shortcut for multiplying that? You're just going to do the first term squared minus the last term squared. Okay, so if you wanted to, we're not going to actually do this in the end, but if you wanted to, you can multiply those two together first. And that is what you will get. Just for these two. Does that make sense? It's a difference of two.
The final one.
No.
I mean, on the two, right?
Have the two brackets, yes.
And then with,
I'll get to that.
I don't really know how to do it.
Yeah. But that's what I'm saying.
These are confusing. That is
Actually, all we use it. All right, guys, listen up. I'm saying I'm not going to go on with this method. I'm just saying maybe you call this and you're like, oh, cool, this is too sweet. Let me do it. Okay, this is what you would get. Whether you foiled it out and simplified, or whether you did this the shortcut and you just got those two. That's fine. Now we still have three brackets though. Okay, so now you would have to take this bracket multiplied by this bracket, still in brackets, because we must still find the product of all of these brackets, right? And that last bracket you would leave as it is for the time being. Okay, does everyone know what I said now? So if you wanted to do this, you then have this bracket now multiplied by this bracket, which you could do as a binomial multiplied by trinomial, right? We just look back here, we can do it. Is this binomial multiplied by trinomial one of these though? Does it follow the same pattern? No, I'm just asking these ones, okay? Don't look at anything else. I'm just asking, does this binomial and this trinomial follow the pattern that we recognized up here? Remember the pattern is this term needs to be squared. We can see that doesn't happen, right? This term needs to be squared to give us that one. We can see that didn't happen either. And the middle term is supposed to be the product of these two with a different sign. That doesn't happen either. But guys, it's still a binomial multiplied by trinomial. You can still multiply them out, like we did in the first line here, and simplify. That answer will then go into brackets, and you must then take every term in those brackets multiplied by every term in each. So in this pair of brackets. So it's going to be a lot of multiplying out. But what if the order around? Yeah. And then you what's happening there? Just talking about what look at the one on the line. Thank you. You guys are excited. Just thank you. Thank you. Look at the one that I underlined. What kind of pattern can we see? Correlation between that's binomial and it's trinomial. Isn't it this huge thing? 3x times 3x is 9x squared, right? Y times negative y times negative y is positive y squared. Now, why did I underline this bracket and not that? Right? Yeah, and also here, there we have a minus. Remember, this pattern that we recognize here, basically if you multiply these two terms together, it will give you the middle term, but you have to change the sign in the middle term, right? If I do 3x times negative y, that's negative 3xy. The middle term is going to be positive 3xy. So do we see that this is going to give us a difference of 2 cubes, these two together? So let's rewrite that with the brackets in that order. 3x minus y times 9x squared plus 3xy, hey?
If you copy it.
Right. Okay, guys, let's catch up. Please, you guys are running a bit anxious. Okay, so let's just quickly look at the other pair of brackets here. Some of you have already done that. 3x plus y, and that one goes to also form the cube pattern, right? Now guys, one thing that I also just want to say is that we are allowed to do this because we have 4 brackets next to each other, meaning that we must have multiplied them all together. So yes, Daniel, guys, no matter what order we multiply them in. 2 times 3 is 3 times 2, right? Is that not correct? So these 4 brackets, we can shift them around so that they give us a pattern that we can use. Right, because it's one term. We can move the brackets around if we want to. Okay, so then this is 3x plus y, and then 9x squared minus 3xy plus y squared. Okay, now let's see. For this difference of 2 cubes, we're going to say what is 3x times 9x squared? 27x cubed, yes? And then I know that all of the terms in between are going to cancel out. So I must just do negative y times positive y squared, and that is negative y cubed. Yes? So this product will give me this bracket as an answer. Now, I'm running out of highlighters here. I have a yellow one still that I can use. This product, it's similar, but it's not exactly the same. Yeah. It's going to be 27x cubed plus y cubed. Right? We say 3x times 9x squared is 26x cubed. Then we say y squared times y squared is positive y cubed. So the product there will give us this. And now what is this, guys? Difference of 2 squares. Do we see that? They're the same terms plus minus. What's 27 squared? I don't know. Oh, you know what? I did know that. I just forgot. Now, right, what is x cubed times x cubed? Careful. X to the 6. Hey, remember that when you are multiplying 2 powers together, they have the same base, and then you add the exponent. Okay, so don't think you've got square 3 now, right? You're doing x cubed times x cubed actually, which is x to the 6. And then what was going in between here? What's the sign? Minus y cubed times y cubed is y to the add 3 and 3. Yes. Yes, yeah. So I didn't actually speak about that. Yes, you could have done that. So you could have gotten this, multiplied these 2 together, and then multiplied afterwards. Yes, that's perfectly fine. Guys, it's just those other methods have a lot of multiplying up. And I feel like when you are doing like 25 multiplications, you might slip up with one of them, but you also might slip up with this. So I think the bottom line is just be careful, especially when you're multiplying up. Make sure that you're getting your signs correct. Because if you make one small mistake, obviously it throws the whole thing up. Yes.
I've got 2 questions.
Okay.
How do you know when it's the difference?
So
Is
if
it the
they,
sum and the binomial?
In between, the plus in between.
Is it when the binomial?
yes, so let me just say that so that everyone can hear. When your binomial has a minus in between, your answer is also going to have a minus. Okay, so then it's a difference. When your binomial has a plus, it's also going to have a plus. Okay, so you always look at your binomial. Yes, I'm going to give you some to practice. So write this down, please. I know you don't all have books yet. I will put it on the board now so that you can start while I hand out books to those who have from me. This is from the AP textbook now, book 1. Guys, for the time being, you don't need to bring book 2. We're only going to work on book 2 stuff, I think, in maybe term 3 or so. I haven't planned my whole year out yet. But I'll tell you when to bring book 2. Okay, so book 1 is the one for now. Now guys, this is technically a homework for Friday only because that is when we're doing AP again. But please start working now. You have 20 minutes. You can finish this in the 20 minutes. All right. It's also good to do these now to practice the stuff that's fresh in your memory so that you can practice what we just done.
So you don't do question number 1 on that.
No, you don't have to do number 1. Number 1 is just more of those fraction ones. Okay, I'm gonna put. Oh, where's my book? The first one on the board. Did you all write that down? Can I take that page off, please? Okay, guys, this is from the first exercise that I wrote down. It could be from different matrix quiz as well. It could be various things. So this is exercise 1.1. Guys, on page 2, all right, and then there's 2 at the top. For doing these ones. And 2, you're doing 3, 8. You already did these, right? This is what for today. I just wrote it down on the book. The others are very similar. The others are just. So you can try the others if you want. All right, but it's all just groupings like this.
Sorry, possibly x minus 2.
X squared plus 2x plus x squared. Yeah. And then the last bracket is x minus. Yes. Yeah, I'm gonna hand out the books. You have a book 2, but not a book 1 yet. Yeah, I'm gonna hand them over. Okay, guys, start working on that while I do book handouts.